Um, Good evening, all of you. Yes, good evening, all of you, and welcome to Spark Academy. Welcome to Spark Academy YouTube channel. Yes, good evening, all of you, and welcome to Spark. So we'll just wait for a couple of minutes to join everyone, and then we start this. Um So, in the previous sessions, we have discussed about electricity. So, today we are going to discuss about electricity part 3, means the continuation of the last class. Okay, in the last class, we have learned about the resistance and the factors affecting resistance, and we have also seen how the resistors are connected in series and parallel, right? So in this, yeah, Bhavna, good evening. Good evening, Bhavna. Yes. Okay. So today we are going to learn about the continuation of the resistance. We have started about the resistance and also the factors affecting resistance. And in the part 1 and 2, part 1 we have studied about the current and potential difference and the Ohm's law. Part 2 we have studied about the resistance, factors affecting resistance and all that. Now today's class we are going to learn about the internal resistance. Okay, what is meant by internal resistance and how it affects how that internal resistance affects the potential in the circuit, and what is actually internal resistance and how does it affects, and how can we connect them in how if batteries are connected in series and parallel, how this internal resistance affects, right? So these are all we are going to learn in today's class. Okay, so before I start, let me introduce myself. This is Anupama, physics lecturer, and this video, this YouTube video, you all are watching through the Spark Academy. Okay, Spark Academy. You can to know more about the Spark Academy courses, you can just download the app and then go to the Play Store, install the app, and then once you install the app, you get all these things like like offline videos, study materials, free tests. Okay, and then previous year question papers with the solutions and all that, right? So that is what Spark Academy gives you. Anyways, we'll discuss more about Spark Academy and its courses once we start this session. Okay, so let me start this session, and yeah, this is as I told you, we are just going to learn about the internal resistance. What is internal resistance here? Yeah, internal resistance of usually we learned about resistance, isn't it? Which opposes the flow of current, right? In the circuit. Like if you draw any simple circuit, you know what happens to the current here? Current starts flowing from the positive terminal of the circuit to the negative terminal, isn't it? This is how the current flows in the circuit, right? Now, when the current starts flowing through the circuit, like you can attach a resistor also, but apart from that, as you all know, whenever the current is flowing from one place to another place, when there is motion, friction should be there. In the same way, here the current is flowing, so in the opposite direction, resistance acts, right? That resistance we have learned as R, right? In the last class, we have discussed about this only. Now, what about this internal resistance? Before we go for the internal resistance, we have to learn another thing, that is EMF. What is EMF here? EMF is called as electromagnetic force. Electromagnetic force, okay. In the term, there is a force, no doubt, but it's not the force actually. This electromagnetic force is nothing but the voltage only, the potential what we discussed and how we represent V outside the battery in the circuit. Like wherever this V acts, no, outside the battery, in the battery this EMF acts. EMF is nothing but electromotive force is the work done to bring the electrons from negative terminal to positive terminal of the battery. Outside, the current flows from positive to negative. Inside the battery, the current flows, electrons flows from the negative to positive. So, in this way, if they are flowing from negative to positive, in the opposite direction of current, the work done to bring that current from negative to positive terminal inside the battery is called as electromotive force. Okay. It is like a potential only. It is just like potential only. So that is about electromotive force. Okay. Right. Now, how do you represent this electromotive force? As E, we know. Right? Yes, Bhavana. It is electromotive force. Good evening, Shailendra. Right? So this electromotive force, once the electrons start moving from the negative to positive terminal of the battery, okay, definitely as resistance is there outside the circuit, here to oppose the flow of these electrons inside the battery, there exists internal resistance, okay, and which is represented by R. Wherever you see this small r, this is nothing but the internal resistance, and that will be inside the battery. Okay. So the battery related terms are E, that is EMF, and R, small r, that is internal resistance. These two are battery related terms, right? Now this is the circuit you can see here. You can see the circuit here. And in this circuit, there is a resistor, and you can see the battery related things, that is EMF and R, right? So, the EMF of the cell, how do you write the EMF of the cell? The total EMF of the cell is written by E is equals to V plus V dash here, okay? So, from Ohm's law, we have V is equals to IR, right? That is, I can write I is equals to V by R. Here, in terms of internal resistance, means we are just talking about internal resistance. So, V becomes E here, that is EMF, by R plus R. What is R here? This R is this is normal from Ohm's law. And this R is internal resistance, and the capital R is nothing but the resistance outside, resistance of the resistor, we can say. Right? So, in this way, when you add the internal resistance and this R, you will get the total resistance of the circuit including the battery. Right? So, that is how we get a formula for I. I is equals to E by R plus R. Right? So, this is about I. Fine. Now, we will see how can this I I be connected? I mean, how can this I we get when the cells are connected in series and parallel? Okay. Now, for example, I am taking 3 to 4 cells. Okay, like series. I will connect them in series. I mean, let us first do one thing, like cells in series. I will take. Okay, cells in series, and I am taking three cells, for example. When can you say that the cells are in series? Like this is positive and this is negative terminal. We know that, right? Negative terminal of the first battery, when it is connected to the positive terminal of the next battery, next cell, then those cells are said to be in series connection. Okay. Now, let us suppose the internal resistance of the cell is R1, R2, R3 and all that, right? And let us suppose the EMF as E1, E2, E3 and all that, right? So, now this is actually the arrangement, and there is a resistor R also here. Now, if R1 and R2 and R3 are equal, then what happens? The total resistor, they are in series, right? So, we can add up, and the total resistor is equal to, total internal resistance is equal to N into R, or as I have taken 3, N becomes 3 according to this circuit. N is the number of cells which are connected in series, right? N into R. Okay. Then what about the EMF here? EMF also N into E only. That is, if E1, E2, E3 are equal, R1, R2, R3 are equal to R, right? Then you can write like this. Sorry. N into E. Okay? Now let us take I is equal to, what is the formula we got from the last page? We got the formula like this. What? This is the formula. Now we will put all those in this formula. That is, I got I is equals to, actual formula is E by R plus R. But here, as they are in series, then we can write I is equals to N into E by R plus N into R. So this is what is the cells in parallel series. Okay. Now let us take cells in series connection. Okay. Now I am taking the cells in parallel connection. This is series connection. Now I am taking cells in parallel connection. When can I say that cells in parallel? I just write here itself. Yeah. When can you say that they are in parallel? Okay. See, this is parallel connection. Okay. And all the positive terminals I am bringing to one side, and all the negative terminals of the battery I am bringing to another side, and then from the ends I am connecting it to a resistor. Right? Anyways, let us take, this is E1, E2, E3, and then all the EMFs are equal to E. Right? Then what will be the total EMF? In the previous case, when they are in series, no? What will be the total EMF? Total EMF we have added, and then we have made it to N into E. Or here, as I have 3, this will be 3 into E, whatever it may be. Right? This is the total EMF. Right? But when they are in parallel, and when the EMFs of the cells are equal, even though how many ever cells they are, n number, infinite number of cells you are connecting them in parallel, then EMF of the total arrangement will be E only. Okay? E only. We are not going to add, neither going to subtract, nor divide, anything we are going to do. Only we will take E, means only one EMF, right? So the total EMF of the circuit is E only. Then what will be the total resistance? Like every battery now we'll have total internal resistance, right? Let us suppose all these internal resistances are equal. Then what will be the total resistance of this particular arrangement? This will be R by N. Like already we have learned now, when resistors are in CD in parallel, the total number of resistors is equal to R by N. That we have already learned. Now we will put this in I formula. I is equal to E by R plus R is the original formula. Then we get I is equals to E is what? What is the total EMF here? E by R anyways is 1 only, and total R will be R by N. Now take the LCM of this. You get I is equals to E by NR plus R by N. If this N goes up, it will be NE by NR plus R. This is the formula for total current of the circuit. Like this is how we are going to find out the total current of this particular arrangement when the batteries are in parallel to each other. Okay. So this is the parallel connection, cells in parallel. Now apart from that, we also have mixed grouping. Now we have taken, in the first case we have taken cells in series connection. In the second case we have taken cells in parallel connection. Now let us take mixed grouping. Okay, mixed grouping in the sense there will be in the same circuit, few cells will be in series and few cells will be in parallel in the same circuit. That is called as mixed grouping. Now what I do is I just rub it and then I will do here itself. Okay. So as I said, this is going to be the mixed grouping. This is not given here, but we will just discuss mixed grouping. Mixed grouping in the sense what? Like as I said, few will be in series and few will be in parallel. Okay. Let us suppose. Let us suppose, see, these are in series, right? Like this. These are in series, and now what you are doing, you are connecting it, bringing it to a same circuit, and then like this I am connecting. Few are in series, right? And then if you see this, the total combination is parallel to the next combination. Means series are there and at the same time they are parallel also, parallel to each other. The total combination is parallel to each other, isn't it, right? So now what we are going to see is, like for example, there are n number of batteries which are in series connection. So let us suppose in series connection there are n number of batteries and the total EMF in the series connection is, total EMF in the series connection is N into E, right? And here also you will get N into E because everywhere you are adding, and here also you will get N into E, right? And then again they are parallel to each other. You can see here they are parallel to each other. Meaning NA is parallel to another NA is parallel to another NA, right? Now what about the internal resistance among these batteries? Total internal resistance among these batteries will be R plus R N into R. Here also it is N into R. Here also it is N into R, right? N into E is parallel to another N into E is parallel to another N into E. N into R also parallel to this. Now we will put in the formula. The original formula we have is I is equals to E by R plus R. Right? That is E. What is E? N here, N here, N here. Right? That means N only you will get. Okay, because so how many ever parallel connection, in parallel connection we take only that particular value only. By R anyways only 1 plus now NR is parallel to NR is parallel to NR. Like how many are in parallel? Let us suppose N number of cells are in series. Okay, in each row, and m number of rows are there. Means each row n resistors are there, and how many rows are there? Let us suppose m rows are there. Okay, let us suppose m rows are there. That means NR is no doubt. This NR, how many times it is parallel? Like, if R are in parallel, we'll take R by N. Isn't it right? R by N times their parallel. Now, NR is parallel. NR by M rows. M. Like that you will get. So, it will be NR by M. Now, take LCM. You get NE by MR plus NR by M. This M goes upside. You get NME by MR plus NR. Okay. So this is how the mixed grouping will be. Like again I'll tell you, I don't know how many of you have understood. Again I'll tell you, mixed grouping is nothing but like even in resistors also mixed grouping is possible. Okay, like if you take a circuit, depending upon the direction of current, we will estimate whether the resistors are in series or parallel, right? That is how we will estimate. In the same way, we have here cells, right? Even in cells also, we have possibility for mixed grouping. Like this is the thing which is actually mixed grouping. That means n number of batteries are parallel series, and m number of things are parallel to each other. Okay, so in this way, like I have taken the total resistance which are in series, and then I have made it to parallel, connected it to the parallel to the m other groups, and then finally I got internal resistance in the mixed grouping as NME by MR plus NR. So this is about the mixed groupings of the sets. I hope this particular thing is clear for you. Right? Now we will go to the next one. What is next one here? This is electrical current. Okay? Electrical current. Right? Electrical energy we say. Okay. So I think you all know what is electrical energy. What is electrical energy? Energy is not leaving about electrical energy. There exist other types of energies also. In your previous classes, you might have learned about different types of energies. Like even in this class, you learned about light energy previously. Isn't it right? You know mechanical energy, and here we have electrical energy. Okay, electrical energy comes from the electric current, passing of electric current from one place to another place. Energy is nothing but transfer of some matter from one place to another place. So here also the same thing. Okay, so one place to another place moving is nothing but this is the work done. Okay, work done. If you are doing something from in sending from one place to another place, that is work done only. In the same way, even electrical energy also, this is the work done to bring the electrons from one place to another place. That is called as electrical energy, right? And this electrical energy is given by usually work done, as I said, work done. Okay, we have a formula for work done from potential formula. We have potential is nothing but work done by charge, isn't it? Work done by charge. Now here work done is equals to potential into charge. Okay, potential into charge. From Ohm's law, we have, what do you have from Ohm's law? V is equals to IR. From Ohm's law, we have V is equals to IR. And from current definition, we have I is equals to Q by T, or I can write Q is equals to I into T. Now this Q formula and V formula I'll put here in work done formula. Then what I get, W is equals to I into R into I into T. So we can write this as I square RT. Okay, I square RT. Or I can also write this as IR into I into T. Right? IR is nothing but V is equals to IR. So this will be VIT. Okay, that also we can write. Okay, now the same, if you take W is equals to I square RT and multiply with R up and down, you get I square R square T by R. This is IR whole square into T by R. What is IR? That is V square. V square into T by R. This is the work done. Okay. So in this way, you can define work done by transferring the energy from one place to another place, or you can also define work done like by the electrical energy consumed by the circuit. Okay. Now from this work done formula, you can say that work is completely depending upon the current, the flow of current. Naturally, the more flow of current, the work done will also be more. Okay. Now next we have electrical power. Power is rate of doing work. Okay, rate of doing work is called as power. Means how can you write this? Power is equals to W by T. What is the formula for W you got? W is equals to I square RT. Isn't it? I square RT by T. TT gets cancelled. This will be I square R. In the same way, how we have multiplied R up and down. Here if I multiply R up and down, I get I square R square by R, which is nothing but V square by R. From this formula of power, we can write power is equals to, power is inversely proportional to resistance. Okay, power is inversely proportional to resistance. This is about the power. Okay, here we just go here and see. Few formulas they have given here. We just see. Yeah. See, heat energy formula also they gave here. Heat energy is equals to W by J, and this is PT by J, W is nothing but P into T only. No, power is work done by time. Work done is power into time. And this will be EIT by J. What is J here? J is called as Joule's constant. Joule's constant. So this is how you can give power, heat energy in terms of work done also. Yeah. Now, next we have is bulbs connected in series. Have you seen any time the bulbs which are connected in series? Yes? Yeah. There are series bulbs in day-to-day life during the functions, during the day. These series bulbs are nothing but the decorative things, isn't it? The advantage of series bulb is, the intensity will be more naturally because the total EMF will be added, right? Our total voltage will be wattage will be added. But apart from that, when you take these bulbs in series, the disadvantage is when a wire is cut in the middle or when any bulb blows off, gets damaged, then naturally all the bulb stops working. Okay, so that is the disadvantage of bulbs. Okay, but any electrical appliance you take, the here you can take, like, in case of the electrical appliances, V is proportional to R. Okay, or P is proportional to R. So in this way, electrical appliances you can give here. Now when the bulbs are in series connection, then the total effective power of the bulb is given by 1 by P is equals to 1 by P1 plus 1 by P2, 1 by P2 plus so on. Okay. So in this way, the total power, effective power can be given when the bulbs are in series. Okay, effective power consumed, right? Apart from that, if total n number of electrical appliances are connected in series connection, okay, then the power dissipated can be given by V squared by NR. This formula anyways we know, V squared by R, isn't it? N is the number of resistors which are connected there. So this is about the V squared by NR. Okay. Now that is about the bulbs which are connected in series connection. Now let us come to the bulbs which are connected in parallel connection. Okay. In parallel connection, power is inversely proportional to resistance. Or anyways, apart from power, we all know that the current also is inversely proportional to resistance. The more current flows in the conductor, naturally we can think that the resistance is less, right? And if the less current is flowing, we have to understand that the resistance is more, or vice versa, right? So here the power is inversely proportional to resistance and current is also inversely proportional to resistance, right? So that is the reason why we can say that the current and the power consumed will be more in the smaller resistance because they are inversely proportional, no? So, in the smaller resistances, if the value of R is lesser, naturally current consumed or power consumed will be more. And for example, if so many electrical appliances are connected in parallel one to the other, I told you how we connect electrical appliances in parallel. One below the other we will connect, right? So, such electrical appliances, when you are connecting parallel to each other, then the effective resistance is given by effective power is given by P is equals to P1 plus P2 plus P3 and so on. That was in series connection. P effective is given by 1 by P1 plus 1 by P2, so on, right? So that is the difference. And in series connection, this is series. In series connection, P is directly proportional to R. I think that difference you might have noticed. And in parallel connection, P is inversely proportional to R, and I also inversely proportional to R. So this particular differences you have to note down. And very importantly, whenever now this particular electricity part 3, in this electricity part 3 we have discussed about, we started discussing about the EMF, electromotive force, right? EMF. We discussed about internal resistance. Okay, these both are connected to what? These are the terms which are related to cells, right? And then we have seen cells in series, cells in parallel, and then next we have mixed grouping. Mixed grouping in the sense cell will be in series and parallel, right? And then we have learned about the electrical energy, that is work done. And the next one is power, bulbs in series, and the next one is bulbs in parallel. So these are all the things we have discussed in this particular session. And now we are going to solve few problems, few numericals which are related to this. But apart from that, anyways we will solve the problems. But one simple thing I want to tell you is, whenever there is some concept completed, please note down the formulas which are related to the concept in a book. Okay, that particular, now we know like few formulas we have discussed here, like we have discussed how the current, variation of current in cells in series, isn't it? I in series, I in parallel, and then I in mixed grouping. And we have discussed about the electrical energy formula, isn't it? Nothing but the work done, right? And we have discussed about the power formula, isn't it? And we have discussed about bulbs in series and parallel. Okay. So now what I am telling is, whatever formulas which are related to this, not only this concept, whenever you learn about any concept, okay, you please just note down in a book. Okay. Last minute preparation, when you are perfect in your formulas, okay, then you can learn more and more, you can do more and more numericals. Initially, any numerical, if you are going to start for the first time, it will be confusing, no doubt about it. And for the first 2-3 times, few numericals will go wrong also. You should not lose your confidence, okay? You have to make mistake. If the first time only, if you do all correct, then there will be something wrong, you have to think. So, first time if it goes wrong, don't mind. Again and again you try and try to get the correct answer, okay? Until you get the correct answer, don't leave any problem. And that problem you will get when you are perfect in your formulas, okay? So this is what is the concept is about. Now we will solve the problems, but before we go, as I told you, this particular YouTube class you are watching to the Spark Academy YouTube channel, okay? And you all know, already I said, go to the Play Store, download the app and then you will see different options there. Okay, and there is a link here in the description, and also the Spark store we have here. All these things we have in the Spark store, and then we have, I mean, now the admissions are open, and we what Spark is offering you: short-term crash course, classroom coaching, long-term short-term coaching, long-term coaching, regular coaching also they give, and the timings are mentioned here. Okay, and we have even online coaching too, that is NEET 2022 online coaching, and JEE Mains online coaching. All the last year's question papers, previous year question papers, and the solutions we are going to discuss in this online sessions. Okay, so even if the advantage of these online classes is, even if you miss one class, okay, due to any genuine particular reason, the recorded classes will be available in the app. You can just go to the app, and whenever you are free, whenever you want, if you have any doubt also, again and again you can watch all these videos. That advantage we have in the Spark store. Okay, and then anyways, every weekend we have tests, and the test analysis will be there, right? So, and this is how the analysis will be. You can just watch it. Okay, analysis will be there, and then we have assignment program. Everyday assignments will be given to the students through online itself in the app. You can just note down, take the assignments, and do the problems, right? And yeah, this is how it is. You can see here. Okay, our methodology of teaching is basic concepts initially, and then shortcut methods, all model questions, exercise questions, previous year questions, chapter-wise tests, weekend tests, grand tests, and the test analysis. Okay, this is how the methodology will be in teaching in the Smart Academy, right? Yeah, we have this particular problem. I think you all are able to see this. Yes? One second. Huh. One and each of a resistance R, capacitance C, and the resistance 2R are connected together. The other ends are respectively connected to the positive terminal, means they are parallel to each other. Means one end are connected to one side, and the other end are connected to the positive terminals, are having respective EMFs E, E, and 2E. The negative terminals of the battery are then connected together. Means whenever, remember one thing, whenever all the positive terminals are connected one side and negative terminals are connected one side, then the current drop, like potential drop, they are asking what will be the potential drop. Okay, potential drop will depend upon, yeah, potential drop across the capacitance they are asking. Okay, so across the capacitance, I mean, when these are connected in parallel, already I told you, right, EMF will not be changing. The same EMF will be there all through the arrangement of the circuit when they are in parallel. Okay, so this is how it is. And the next one we have is um, huh, yeah. Yeah. Huh. The next problem. I hope that one is clear. Remember one thing. Whenever the batteries are connected in parallel, then the EMF will be same. Two batteries of different EMF and internal resistances connected in series with each other and with an external load resistor. The current is 3.0 amperes. When the polarity of one battery is reversed, the current becomes 1.0 amperes. The ratio of EMF of two batteries is, okay, ratio of EMF of two batteries they are asking. Like first, they gave I1 is equals to 3 amperes. 3.2 means 3 amperes only will take, and I2 is equals to 1 ampere only will take. Okay. Then what is the what they are asking, ratio of the EMS, right? Okay. Anyways, ratio of the EMS we will take, but what is the total current here? Total current, initially the current, two batteries of different EMF and different internal resistance is asking. So when they are in series, that means we can write E1 plus E2 by R plus R1 plus R2. Isn't it? Original formula is E by R plus R. Right? So this is E1 plus E2 by R plus R1 plus R2. Initially it is 3. Okay? Now I can write, I can write this as R plus R1 plus R2 is equals to E1 plus E2 by 3. Okay? By 3. Yes. Yes. So next what he is asking, the polarity is of one battery is reversed, he is asking. Actually there are two batteries and the polarity of one battery is reversed and the current becomes 1 ampere. One battery is reversed. Okay, then we can write E1 minus E2. E2 is reversed is equals to R plus R1 plus R2. Okay, this is actually by 1 it should be anyways, because 1 ampere you are getting. No? Now equating all these you get, this I can write as 3, I think, isn't it? This I can write as E1 minus E2 is equals to E1 plus E2 by 3. This you bring it here, you get 3E1 minus 3E2 is equals to E1 plus E2. Right? Now this E1 comes this side, it will be minus E1. So you will get 2E1. 2E1 is equals to this 3E2 comes this side, it will become plus. So you will get 4E2. Okay? That means E1 by E2 is equals to 4 by 2. This will be 2:1. This will be the answer. Okay? I hope this is clear. Right? Okay. Any doubts you have here? Just ask me if you have any doubts. I don't know how many of you are watching. Bhavna, are you there? tell. So the next one we'll see. A 1000 watts heating unit is designed to operate on a 120 volt line. The line voltage drops to 110 volts. The percentage of heat output drops by. Now here, okay, V is equals to V1 is equals to 120 volts. P is equals to 1000 watts and V1 is equals to 120 volts. Okay, V2 is equals to 110 volts. They're asking P2 is how much? What is the formula we have here? P is equals to V square by R. I think you remember this, isn't it, right? So we can write P2 by P1 is equals to V2 square by V1 square. P2 minus P1, P2 by P1 minus 1 is equals to V2 square by V1 square minus 1. I am like, equating, with minus 1 I am doing. I get P2 minus P1 by P1 is equals to V2 square minus V1 square by V1 square. This will be V2 square is 110 whole square minus 120 whole square by again 110 whole square is equals to P2 we have to find out minus 1000 by again 1000. So in this way you need to find out and multiply it with 100 both sides because they ask the percentage here. If you are multiplying both sides 100 then you get the percentage drop of 16%. Then D will be the answer. You have to simplify it and find out P2. Then you will get the percentage of it. So this is how you are going to solve this problem, right? So this is about the power, work done, energy and all. Okay, we have a very important topic in our next session, that is Kirchhoff's laws and Wheatstone bridge. I think you all might have heard about the Kirchhoff's laws, isn't it, right? And the Wheatstone bridge too, right? So we will be discussing the Kirchhoff's laws and Wheatstone bridge in our next YouTube session, right? So as before I end, again I tell you this, like this particular thing, this particular YouTube channel, you are watching from the Spark Academy, and we have even the Telegram group also. You can just go to the link, go to the Telegram and then type Spark Academy and all that. So these are the seats Spark Academy got in 2021, right? Okay. So this is what we have here. Subscribe to our channel, YouTube channel. Press the bell icon for the notification and and then watch all the live videos of all the classes and all the sessions, which are very useful, right? So thank you everyone. I hope this particular class or this particular session was very useful for you. For any queries or for any doubts, you can just type in the comment section. If you have any doubts or want to ask any question regarding this session, you just type in the comment sections, type your question, and definitely I will come back with an answer. You can just post your questions also, the questions those questions you are unable to find out the answers, you can just post in the comment section. I'll come out with the answers, right? Thank you so much. Thanks for attending, and we will come with a new chapter, new particular new session, new topic in our next session. Thank you all, and until then, have a